For more problems and videos like this for linear algebra, you can take a look at Sarai Studies, link is in the description box below. So far, we have started with the system. I've shown you how to rewrite that system in a matrix called A. I showed you what a matrix in row echelon form looks like, and also what a matrix in reduced row echelon form looks like. But then the big question is, how do we get from matrix A to row echelon form or from matrix A to reduced row echelon form? Well, the answer to that is that there's these recipes that we can follow, these algorithms, these series of steps to get to these forms. To go from matrix A to row echelon form, that's called Gauss elimination, or simply just row reduction. And then to get from matrix A to reduced row echelon form, it's Gauss elimination plus just a little bit more. Because you can see that reduced row echelon form is literally row echelon form, so you have to do Gauss elimination, just reduced a little bit more. So we call that Gauss-Jordan elimination. Now these are recipes. These are series of steps that we have to follow, and just like any recipe, we need tools, pots and pans to perform these recipes. So what are our tools? And we went over those tools are called elementary row operations. These are 3 operations that we can use to get our matrices to look differently but still have the same values, still be the same matrix, still be equivalent to the original matrix. We discussed elementary row operations in the last video. In this video, we're finally going to be getting into following the recipe using these tools, our pots and pans. So our input is going to be any matrix A. Let's say this is our matrix A, and our output is going to be row echelon form of A, so this. And what is the procedure we're going to do? We want to get to row echelon form, we do Gauss elimination, or also known as simply row reduction. Now these are the steps, the recipe that we have to follow. Again, we're going to be using elementary row operations to follow these steps. But before we do, I want to discuss a vocab word. So let's say that this is my matrix A. There is something called a pivot position. A pivot position is a position that contains your leading entries. So let's actually identify our leading entries. Remember that our leading entries is just the first non-zero number that we see in a row. So you start with the first row, you go until you see the first number that's not zero, that's this one. That's my first leading entry. Then we go to the second row, we go until you see a number that's not zero, so that is your leading entry for this row. And lastly, you go until you see a number that's not zero. All of them are zero, so that means there's no leading entry for this row. So these here are what we call our pivot positions. They simply just contain leading entries. Specifically, your pivot positions are those that contain your leading entries after you're in row echelon form. And finally, we have something called pivot columns. Pivot columns are literally just the columns that contain your pivots. So it would be this one and this one. And then the non-pivot columns are those that don't contain your pivots. So keep that in mind while we get started. The first step is to start with the leftmost non-zero column. In other words, go through the columns, and if you see that they're all zeros, just skip it and start with this column right here. Then it's saying that the pivot position is at the top of that column. The second step is to select a non-zero entry in that column to be the pivot. Move it to the pivot position. In other words, any pivot position that we have, don't want it to be zero. So we can select any one of these to go up here, and if we move one of them up here, then we have to remove the rest of them also. The elementary row operation that we're going to do is switch these 2 rows. So label your rows if it helps you. This is row 1, row 2, and row 3. So we want to switch row 1 and row 2 to get this 2 up here. So this is going to become our first row, and then this is going to become my second row. And then my last row stays the same because I didn't do anything with it. And my pivot position stays in the same spot. Now I have a 2 in there. But if it already had a 2 or a 1 or a 3, anything other than 0, then we wouldn't have had to do this step. So this is just if it's necessary. Finally, we kill the entries below that pivot. In other words, make them 0. So this entry is already 0, so we're good. But then this one is not 0, so we have to kill this entry. So the way that I do it is I say, okay, I want to kill something. What row is that something in? Well, that's in row 3, because this is row 1, row 2, and this is row 3. So I want to kill something in row 3. And you always want to use whatever's in your pivot position to kill it. So then you ask yourself, what row is my pivot in? It's in row 1. You say, okay, I want to kill something in row 3. But I want to use my pivot position in row 1 to do so. Then you always do a plus, and then whatever's here, you put it in here. So these should always match row 3. And then what I do to figure out what to change in order for this to be 0, I just write the rows that I have here. So I do row 1, row 3, and I literally just copy them. So I'm going to do row 1 here, and then I'm going to copy row 3 here, and then I treat it as an equation, so a plus, just like I'm saying. And then I ask myself, what's my goal? The goal is for this to be 0, because I have to kill all of the entries below this pivot, in other words, make them 0. So I count, okay, this is my second entry that has to be 0, so my second entry, this one, has to be 0. So then I just focus on this column and I ask myself, okay, when I do 2 plus 4, how can I make that be a 0? Because that's my goal. Well, if this was a negative 4, then when I would do negative 4 plus 4, it would be a 0. So then the question becomes, how do I make this a negative 4? Well, I would just need to multiply by negative 2. But if I multiply this by negative 2, I have to multiply everything else in the row by negative 2. Similarly, when you're solving an equation and you do something to one side, you have to do it to the other. Same thing. When you want to do something to one entry, you have to do it to all of them in that row. So that's why we're going to do negative 2 row 1. When we do negative 2 row 1, this becomes a negative 4, this becomes a negative 2, and this becomes a negative 2. And then it just simply becomes an addition problem. So you're going to do 0 plus 0, that's 0. Negative 4 plus 4, that's 0. It's what we wanted it to be. 3 minus 2, that's 1. Negative 2 plus 1, that's minus 1. And then whatever you see here, that is what goes here. That's your new row 3. So this here, we call this the row switching operation, our first operation, or row swapping. Then this here, we did two things. We did row scaling because we scaled row 1 by negative 2. And this whole thing right here is called row addition. We added 2 rows together. So because the only thing that I changed is row 3, I'm going to take my matrix over here. And the only thing that I will change is row 3. It becomes this right here. Now, my goal was to kill this, and now I did. It's a 0. Perfect. Now, the fourth step is to repeat these same steps on the submatrix formed by the remaining rows and columns. What do I mean by that? You take your pivot position, and all you do is you're going to cross out its corresponding row and column, like so. And then this here is the submatrix that's formed. So you treat this as its own submatrix, as if this was the one that's giving to you, and then you perform these same steps again. You start with the leftmost non-zero column. In other words, are there 0 columns here? No, they actually have numbers. So this is the column that we're going to start with. The pivot position is at the top. So this is the top one. Therefore, that's our pivot position. Select a non-zero entry in the column to be the pivot. There already is a non-zero entry there, so this step is not necessary. Unlike here, where the pivot was a 0, we had to do row switching or row swapping to get it to be something that's not a 0. But here it's a 1, it's actual number that's not 0, so we're good. And finally, step 3 is to kill the entries below it. In other words, this needs to be 0. Right now it's a 1. The thing that I want to kill is in row 3. I want to use my pivot position to kill it. So where is my pivot position? In row 2. Then I'm going to add whatever's here. So row 3, so these should always match. And then to find out what I actually need to do in order to get this to be a 0, I'm going to write the rows down here. So row 2 is this one. Row 3 is this one. I'm adding, so I'm going to put a plus sign. And then I ask myself, what's my goal? Well, the goal is for this to be a 0. Then I count 1, 2, 3. That's my third entry. So 1, 2, 3. This here is supposed to be a 0. And then I just focus on this column and I'm like, okay, when I add 1 plus 1, how can I get that to be a 0? What can I change? Well, if this was a minus 1, then when I do minus 1 plus 1, it would give me 0. And notice, why am I asking what can I change in row 2? Because my pattern is I always use my pivot position to change the value to be what I want. So here I had to do negative 2 times row 1. So in this case, all I have to do is a negative 1 times row 2. Because when I do negative 1 times row 2, this is just going to be a negative, and then these are just still zeros. And then I add, as always, this becomes 0 plus 0, that's 0, 0. And then this is what I wanted it to be, and then this just becomes negative 1 because 0 plus negative 1 is negative 1. Then whatever's here goes down here. So this is my new row 3. So because the only thing that I changed is row 3, these 2 rows, I'm going to copy them down here because they're the same. And then row 3 is now this. Now, did I manage to take my pivot position and clear all of the entries below it to be 0? Yeah. Then I repeat steps 1 through 3 on the submatrix formed by the remaining rows and columns. What do you mean remaining rows and columns? That just means cross out the row it's in and the column it's in, and whatever is left is your submatrix. So this here is the only thing in the matrix. So if you go back and repeat steps 1 through 3, you start with the leftmost non-zero column. Well, this is the only column, it's not 0. The pivot position is at the top, so this is now the pivot position. Then you select non-zero entry in the column to be the pivot. This negative 1 is a non-zero entry, so it could stay in the pivot position. And then we kill the entries below it, but there aren't any entries below it, which means we are done. This matrix is now in row echelon form. We can use ZO to check, are all 0 rows at the bottom? There are no 0 rows, so that's fine. Does it pass a staircase hack? Well, we need to identify leading entries for that. Leading entry is this one. Leading entry is this one. Leading entry is this one. Does it pass a staircase hack? Well, we start here. We only go down when we see a leading entry. Go, go, go. Down when we see a leading entry. It passes a staircase hack because each step is just height of 1. So that's good. Are all entries below the leading entries 0? This is leading entry, this is leading entry, this is leading entry. Are all entries 0 below it? Yes. And then this one doesn't have any leading entries below it, so unapplicable. It passes so it is in row echelon form. And this is the algorithm, the recipe that we used to get it into row echelon form. This matrix and this matrix are the same. They represent the same system of equations, the same lines. They just look differently. Now in the next video, I'll show you how to go from row echelon form to reduced row echelon form.